From a point to a line. This is our general formula, ax plus by plus c is equal to 0. This is our point slope form, y equals ax plus b. It's also called the functional form. If we had a line segment, this was our line segment, and we had a point P right up here, and we want to find the distance. Let's call this point P. It has coordinates x and y. In terms of our vertice formula, which we'll look at in a second, this would be x, c, y, c. This is my point A. It's on the y-axis. This is the y-intercept, which is negative c over b. So this would be our xa and our ya. Point B is on the x-axis. This would be our x-intercept. Negative c over a is our x-intercept, comma 0. We're going to call this xb and yb when we look at our area of the triangle formula given the vertices. Our area of the triangle is the absolute value of xa times yc minus yb in brackets plus xb times open bracket ya take away yc close bracket plus xc times open bracket yb minus ya close bracket. Absolute value of that divided by 2. The xa is 0. 0 times anything is 0. So I have 0 times the yc is the y value. Take away yb, the yb is 0. Then we have xb, which is negative c over a, times the ya, which is negative c over b, times the yc, which is y minus y. Then we have the xc, which is the x value, times the yb, which is 0, plus the ya, which is negative c over b, minus negative c over b is plus c over b. This 0 multiplies this bracket and becomes 0. Let's look at the length of this base. In our area of the triangle, we have base times height divided by 2. The base, the distance between these two, I'm going to use my distance formula, is the square root of delta x squared. Delta x, the xb, take away the xa. The xb is negative c over a. Take away the xa is 0. We're left with negative c over a all squared. The delta y is the yb, which is 0. Take away negative c over b, which is plus c over b all squared, which gives us the square root of c squared over a squared plus c squared over b squared. To get a common denominator, I'm going to multiply the top and bottom here by b squared. I have b squared times c squared over a squared b squared. Here I'm going to multiply the top and bottom by a squared. I have a squared c squared all over a squared b squared. Then I can write them over their common denominator. I'm just going to put the a first. I have a squared c squared here plus the b squared c squared. I'm just going to write it over here. Then I am going to factor out the c squared. I'm left with a squared plus b squared in brackets times c squared divided by a squared plus b squared. I'm going to take the square root of the c squared and the a squared and the b squared, pull it outside the square root. I'm left with c over a times b times the square root of a squared plus b squared. That's the base. Replace the base in this formula with this. We have c over ab times the square root of a squared plus b squared times h is equal to the absolute value of this negative c over a comes in, multiplies this negative c over b, giving us positive c squared over ab. The negative c over a multiplies this negative y, giving us positive c over a times y. Then the x comes in, multiplies the cb. We have cb times x. I am going to get the h alone. I'm going to divide both sides by this, divided by the square root of the a squared plus b squared. Dividing by c over ab is the same as multiplying by the reciprocal. The reciprocal of c over ab is ab over c. That ab over c is going to come in and multiply each of these terms. When ab multiplies c squared, I have abc squared. The c multiplies the ab on the bottom. I have abc on the bottom. Here, the ab multiplies the c, so I have abc. The c multiplies the a on the bottom. I have ac times the y. Plus, the ab multiplies the c, giving us abc. The c multiplies the b, giving us bc. Then I'm going to start canceling. I'm going to cancel the a's here and the b's, and one of these c's is going to cancel with the c on the bottom. I'm just going to be left with c here, which I'm going to write back here. Here, the a and the c cancel. I'm left with by. Then here, the b, c's cancel. I'm left with ax. We have ax plus by plus c all over the square root of a squared plus b squared. This is the distance from P to the line. The distance from a point to a line is the absolute value of ax plus by plus c all over the square root of a squared plus b squared. That's it in general form. But what if you want it in point slope form or in functional form? Knowing that a, the slope, is negative a over b, the b value is the y-intercept is negative c over b. I'm going to cross multiply the a and the b. I'm going to get the negative a alone. If I multiply both sides by negative b, I end up getting a is equal to negative ab. I'm going to replace this a with negative ab. Instead of a squared, I have negative ab squared plus b squared. Square that. That gives me a squared b squared plus b squared. Factor out the b squared. That's going to give me the absolute value of ax plus by plus c all over the square root of a squared plus 1 times b squared. Pull the b squared out from inside that square root. So I'm basically taking the square root of b squared. We're left with a b. That b is going to divide each of these terms. We're left with a over bx plus b over by plus c over b. We have to realize that a over b, negative a over b is a over b is negative a. I'm going to replace this with negative a. And then b over b is 1 plus 1y. Negative c over b, is my lowercase b, is my y-intercept. Positive c over b is negative lowercase b. I'm going to factor out this negative. When I factor out the negative, I have negative of ax minus y plus b. Because we're taking the absolute value of that, the absolute value of a negative is a positive, this is going to become positive. The absolute value of ax minus y plus b all over the square root of a squared plus 1. This is the distance from a point to a line in point slope form or in functional form. Have a good day.